In the 4th century BCE, the Greek philosopher Democritus suggested that the universe was made of indivisible units called atoms. Democritus developed this theory just based on what his observations of the natural world were, so he did not have evidence for his atomic theory. According to Dalton, all atoms of a given element are exactly alike, and atoms of different elements could join to form compounds. So unlike Democritus, Dalton did have experimental evidence. He developed the law of definite proportions, where he said a chemical compound always contains the same elements in exactly the same proportions by weight or mass. For example, water we know is H2O, so 2 hydrogens and 1 oxygen. And by mass, water is always 89% oxygen, 11% hydrogen. For any given sample of water, the proportions are going to be constant. This fact suggests that water molecules are made up of atoms that combine in simple whole number ratios, and they combine the same way each time. Dalton's theory did not fit all observations. So next was J.J. Thomson, and he developed the cathode ray tube experiment, and through experimentation with the cathode ray tube, he discovered that there were negatively charged particles that came from inside atoms. So Thomson developed what's known as the plum pudding model. In his cathode ray tube experiment, Thomson had discovered electrons. An electron is a subatomic particle that has a negative charge. Thomson's plum pudding model says that electrons are spread throughout the atom like plums in plum pudding or blueberries in a blueberry muffin. Rutherford proposed that most of the mass of the atom is concentrated in the atom's center. Ernest Rutherford conducted the gold foil experiment, and he discovered the nucleus of the atom. The nucleus is an atom's central region, which is made up of protons and neutrons. And so Rutherford's model of the atom consisted of mostly empty space with the small dense nucleus in the center and the electrons orbiting around the nucleus.